Hello, yeah, welcome back. And we are solving the question from IITJEE 2012, and this is another question from the complex number maths. Okay, and the question is from IITJEE 2012, as I said earlier, and it's the let z be a complex number such that the imaginary part of z is non-zero, and a is something given which is real. Then we have to find. Then it's a single correct question, and we have to find then the value of a. Then a can't take the value. We have to find that particular value which the a can't take. So simply the thumb rule says that we have to just simply put z equals to some x plus iota y. Why? Since this question from complex numbers, okay, it's cn, from cn. Okay, then the thumb rule is, if nothing is striking mind, then the thumb rule is put z equals to x plus iota y. Okay, simply on putting z equals to x plus iota y here. Okay, taking this a to RHS, we will get z square plus z plus 1 minus a equals to 0. Okay, then from there we put z equals to, what we put there is z equals to x plus iota y. What we put is z equals to x plus iota y. Okay, then we get x square plus x plus iota y ka whole square, which is this, and z, which is x plus iota y plus 1 which is this, and minus a. Why? Because we took a to this side. Okay, then we got something like this. Okay, since it is equal to 0, and we have learned, if you studied complex number, then you will know thing that what we do is, if something is equal to 0, if a complex number is equal to 0, then what we do, we equate the real and the imaginary parts. What that means, that if a complex number is 0, then the sum of all the real parts of z is equals to 0, and the sum of it simply means that the real part is 0 and the imaginary part is 0. Okay, then from here what we put is, since a complex number is equal to 0, what we do is we simply put the real part is 0. Here we put real part as 0 and imaginary part as 0. First we are putting imaginary part as 0. Okay, imaginary part as 0. And one thing I would like to say is that simply watching will not help you, nothing will do. You must pause the videos and try yourself first. Okay, then what we did is we equated imaginary part to 0 and real part to 0. Okay, since we have written this imaginary part as 0, imaginary part is 2xy iota. Since there are two parts which are imaginary, this and this, 2x y iota plus I iota. Okay, this is equals to 0. Okay, and taking y common, we get y into 2x plus I equals to 0. 2x plus 1 equals to 0, then equals to 0. Y can't be 0. Why? You must think yourself. You must think. Pause and think. Read the question again. And why should not be 0? Think on that. Okay, then I am saying now that y is 0. Why can't be 0? Because since it's written that this is that imaginary part of z is non-zero. If z is non-zero, we have taken z as x plus iota y. That means y should not be 0. That means this y is not 0. From here what we got is 2x plus 1 equals to 0. It simply means that x equals to minus 1 by 2. Okay, and also since we put imaginary part as 0, also r part simply means real part as 0. Real part is 0. Okay, then we are putting the real part is 0. x square plus x square minus y square plus x minus a plus 1. These are all the parts from the real parts. Okay, the sum is 0. Okay, this is 0. Okay, now what we do is we simply we got x equals to minus 1 by 2 from here, and we put x equals to minus 1 by 2 here. Okay, we will get this, and from here what we will get is, we will get a equals to 3 by 4 minus y square. Okay, a equals to 3 by 4 minus y square, and it's given over that this part again, that z is non-zero. Z is non-zero simply means y is non-zero. If y is non-zero, it means here y can't be 0. Y can't be 0. That means if I put y is 0, which is never possible. That means if I putting y is 0, I am getting 3 by 4, but y can't be 0. That means a cannot be 3 by 4. From here I got is a cannot be 3 by 4. So the correct choice over here is D. Okay, we got D as correct choice. But The another approach is, since it took, I think that in the examination it will took, since we are putting our x plus iota y, then it will took 2 to 3 minutes. Then we have to minimize our time. We have to use some tricks over here. In the examination we have to use the tricks. Okay, wait a second, let me clean. In the examination what we have to do is we have to minimize our time. We have to use the tricks. Okay, then what we have given is a equals to z square. Then this was the first approach, and we are going for a second approach. Okay, so this is second method. Okay, we have given a equals to z square plus z plus 1. Okay, since then I am making a quadratic in z, that means z square plus z plus 1 minus a is 0. Since it's a quadratic, since it's the equation of a complex number, then its roots are necessarily non-real, imaginary. For non-real roots, we know that discriminant must be simply less than 0. If discriminant must be less than 0, and we know that in general equation ax square plus bx plus c, ax square plus bx plus c, the discriminant is given a b square minus 4ac. b square minus 4ac must be negative. Putting okay, should be negative. I'm writing capital because small is given over here. Okay, it should be negative. Okay, then what we got, b1, b is 1 here. Okay, compare it with ax square plus bx plus c, b square minus 4ac, minus 4, a is 1, a capital A is 1, and c is 1 minus a. It must be negative. It must be simply negative, nothing more. Okay, then what we will got is 1 minus 4 plus 4a must be less than 0, and what we will get is 4a must be less than 3 by 4. 3, it simply means a must be less than 3 by 4. This is the another way from where we getting that a is less than 3 by 4, that a can't take 3 by 4. This is the shortest approach, and we will get this in hardly 10 to 15 seconds. So this is a better way. Okay, then you have to think for different approaches that from where you can minimize your time. Okay, and if nothing is striking, then this is a fine way. And okay, then okay, then thank you, and I will be uploading more from, okay, I am working on to upload more as soon as possible. Thank you.